Okay, good morning everyone, and welcome back to Algebra 2. I know for some of you it's been a long time, so for the next couple of days I'll take it a little slow and we will review a couple things along the way. We're going to start with Chapter 6. We ended with Chapter 5. Our objective today is to classify and write polynomials in factored form. What is a polynomial? And then we'll add and subtract polynomials. So let's recall something you learned before. Okay, so in Chapter 5, we worked with quadratics. Quadratic functions like f of x is equal to x squared minus 2x minus 8. And then to recall, we found the zeros or the roots or the x-intercepts. It all means the same thing of that quadratic function. So we set one side equal to 0, so f of x equals 0, and then we factored x squared minus 2x minus 8. So factors of x squared minus 2x minus 8, and that would be x minus 4 times x plus 2. And then we found the zeros. We set each factor equal to 0. X minus 4 is equal to 0. And so we got our x-intercept, our 0, or our root of x is equal to 4. And then we set x plus 2 is equal to 0, and we got x is equal to negative 2. So those were our roots, our zeros, our x-intercepts. And you can clearly see that on the graph. So remember graphing the quadratics. So my root, or 0, was 4. And then my other root, or 0, was negative 2. And you can see that. That's where the quadratic crosses the x-axis. The x-intercepts, the roots, the zeros. So we did a lot of that in Chapter 5. Let's look at this one here. Here I have not a quadratic. We'll say this is a cubic, okay, because rather than an x squared, I have an x cubed. So we have f of x is equal to x cubed minus 2x squared minus 8x. I can still find the zeros, the roots, or the x-intercepts of that cubic. I first factor out an x, and then I have left over x squared minus 2x minus 8. Okay, but x squared minus 2x minus 8, I just factored that before. If you look up here, that's the same thing. And that was x minus 4 times x plus 2. So there you see I have three factors. I have x as one factor, x minus 4 as another factor, and x plus 2. And then I can find the zeros of each of those factors. I set each factor equal to 0. So x is equal to 0, that's one x-intercept or root. If x minus 4 is equal to 0, x is equal to 4 is another x-intercept or root. And then x plus 2 equals 0. X equals negative 2, that's another 0 or root. And as you can see by looking at the graph, I can see all of those x-intercepts or roots. So negative 2, and I see 0, and I see 4. So again, the x-intercepts is where the graph crosses the x-axis. Right. So in this chapter, we'll be finding the zeros, the x-intercepts or roots, not just of quadratics, because we did that in Chapter 5, but we'll be finding the zeros, roots, or x-intercepts of higher degree polynomials, x cubed, x to the fourth, and x to the fifth. Okay, so let's look at some vocabulary. What's a monomial? Monomial, one, meaning one, so one term. So for example, like 3 is a monomial, or 5x is a monomial, or 7x squared is a monomial, negative 8x cubed is a monomial, just one term. A polynomial, we'll say, can be a monomial, it could be a binomial, a trinomial. Okay, we'll define polynomial in just a second here. But polynomial could be just about any type of term. Monomial, binomial, trinomial, so on and so forth. The degree of a monomial, okay? We'll define what the degree of a monomial is. In the degree of a polynomial, the leading coefficient, binomial, trinomial, and polynomial. So let's look at all of this all of this vocabulary here. So what is a degree of a monomial? Well, it's what the variable is raised to. So if I have negative x cubed, I would say that the degree of that there is degree 3. So this would be degree 3. I have 7x squared. That would be degree 2. And then I have 5x, so that would be x to the first, so this would be degree 1. And notice here I have just a 3, but I could write that as 3 times x raised to the 0, and so that would be degree 0. Okay? Now, leading coefficient for each of those, the leading coefficient for 3, well, that's just, or 3 times x raised to 0, that's just 3. The leading coefficient for 5x to the first, well, that would be 5. The leading coefficient for 7x squared, well, that would be 7. And the leading coefficient for negative 8x cubed, that would be negative 8. Now, let's look at a polynomial. Okay, what is a polynomial? Okay, the degree of a polynomial, well, I still haven't defined a polynomial, but I like to take a look at it like this here. I have a polynomial. Now, what is a polynomial? Well, it's a catch-all phrase. It's a catch-all phrase for, could be a monomial, one-term monomial. It could be a binomial, 2 terms. So what would be a binomial? A binomial would be something like x plus 2 has 2 terms, x squared minus x, it has 2 terms, x cubed plus 1, and has 2 terms. A binomial. Polynomial, a trinomial also falls under the category of a polynomial, trinomial, and we worked with trinomials a lot in chapter 5. So a trinomial, so for example, x squared plus x minus 4, that's 3 terms, trinomial. Or we could have x cubed plus 2x minus 1, that's a trinomial, or x to the 4th plus x squared minus 1, that's a trinomial. So polynomial could be a monomial, 1 term, binomial, 2 terms, trinomial, 3 terms, and then anything more than 3 terms, we just call it a plain old polynomial. So a polynomial could be just about almost anything, a monomial, binomial, a trinomial. The degree of a polynomial is given by the term with the greatest degree. A polynomial with one variable is in standard form when its terms are written in descending order by degree. So for example, let's say here I have x to the 3rd plus 2x to the 5th plus 1. Okay, it's a trinomial, has 3 terms. Well, what would be the degree of that polynomial? First, I have to order it so that its terms are written in descending order by degree. Here I have degree 5, degree 3, and this is 1 times x raised to 0. That would be degree 0. I have to order those by degree. So that would be 2x to the 5th comes first, plus x cubed comes second, plus just 1. So the degree of that polynomial is given by the term with the greatest degree. So here, this would be degree 5. That would be degree 5 polynomial. You first have to write it in standard form. Standard form is when the terms are written in descending order by degree. As another example, if I have 2x plus 3x to the 4th, okay, what would be the degree of that polynomial? Well, I have to write it in standard form. 3x to the 4th plus 2x. The degree would be degree 4. So this would be degree 4 polynomial. So in standard form, the degree of the first term indicates the degree. In standard form, the degree of the first term indicates the degree of the polynomial, and the leading coefficient is the coefficient of the first term. So with this one here, the leading coefficient would be 2. With this one here, the leading coefficient would be 3. All right. So here they give us a polynomial, 5x cubed plus 8x squared plus 3x minus 17 is written in standard form. The degree of that polynomial, well, that would be 3, and the leading coefficient would be 5. Okay. A polynomial can be classified by its number of terms. A polynomial with 2 terms is called a binomial, and a polynomial with 3 terms is called a trinomial, and in anything with more than 3 terms, we just call it a polynomial. We can classify a polynomial can also be classified by its degree. Okay, so this is degree 0 polynomial for -9, because I can write -9 times x raised to 0. Linear degree, or degree 1, so x minus 4, will be linear. Degree 1, quadratic, okay, quadratic degree 2. So x squared plus 3x minus 1. That would be a quadratic. We would call that a quadratic trinomial. This linear term, we could say that's a linear binomial. So we could say this is a linear binomial. And then we can say this is a quadratic trinomial. Okay, quadratic trinomial. And then we have a cubic, so degree 3, and we would just call that a cubic polynomial because it has more than 3 terms. So we would just say cubic polynomial. And then we have a quartic, meaning degree 4. So again, that would be a quartic polynomial. And then a quintic polynomial. Again, anything with more than 3 terms, we just call it a polynomial. So we could classify a polynomial by degree and by number of terms. Okay. Now let's look at graphs of polynomial functions. Here, degree 1 is just a linear function. Degree 1, that's x raised to the first. That's a linear binomial. We have a quadratic function, degree 2, like x squared plus 4x plus 4 would be a quadratic function, degree 2. And then I have a cubic function, so like x cubed minus 2x squared minus 8x. That would be a cubic trinomial. And then I have a quartic function, degree 4. X to the 4th plus 9x cubed plus 16x squared minus 30x minus 80. Now in a couple of days, you'll be able to look at these graphs here, and you'll be able to write the polynomial like I did for degree 3 and degree 4. Okay, for that degree 3rd polynomial, that's x cubed minus 2x squared minus 8x. You'll be able to look at that graph and say, I can write a polynomial for that. And then this is degree 4. You'll be able to look at that graph, and then you'll write a polynomial for that. Okay. Now we're going to look at writing polynomials given the x-intercepts. We're going to write it in intercept form. Factored form, I guess, is probably the better way to say that. Intercept form or factored form. Okay. If a is an x-intercept, 0 root of a polynomial where x is equal to a, then the factor form or intercept form for a is x minus a. Okay, let me go back when I started. To recall, here my x-intercept, my 0 or root was x is equal to 4. If my 0 is x is equal to 4, then the intercept form or factored form, well, I'd have to subtract 4. X minus 4 will give me 0. So my intercept form or factor form will be x minus 4. In other words, the factor that gave me the 0 of 4 was x minus 4. Okay. So there's my 0, but there's my factored form, x minus 4. if my 0 is x is equal to negative 2, if I add 2 to both sides, make the right side 0, the intercept form or factored form will be x plus 2. So if my 0 was negative 2, then my factor was x plus 2. I just reversed finding the zeros. Okay. So that's all that is saying there. Okay, and again, if my 0 here was x is equal to 4, then my factor would have been x minus 4. That would have given me the 0 of 4. Again, I would just reverse. I would make the right side equal to 0, so I have to subtract 4. So that would be the factor for the 0, x is equal to 4. If x is equal to negative 2, I have to add 2, make the right side 0. Then the intercept form or factor form will be x plus 2. And if my 0 here was 0, well, then my factor was x. All right. So my factors would have been x minus 4, and x plus 2. And you can see that's what I got when I factored that. That's what we call the factored form of a standard form polynomial, or the intercept form. Okay, so that's what that was saying there. If a is an x-intercept 0 root of a polynomial, or x is equal to a, then the factor form or intercept form for a is just x minus a. So you just make the right side equal to 0. They have to subtract a. There's the factored form. Now, every polynomial function of degree n will have at most n minus 1 bends or turning points in the graph. So if I have a degree 1, I have 0 bends. If I have a degree 2, I'll have 1 bend. If I have a degree 3, notice here I have 2 bends, 1, 2. If I have a degree 4, I'll have at most 3 bends, 1, 2, 3. If I have a degree 5, I'll have at most 4 bends, 1, 2, 3, 4. That's going to be important as we move ahead. So every polynomial function of degree n will have at most n minus 1 bends, or turning points in the graph. That's going to be important as we move forward. Let's say we have the x-intercepts or zeros of negative 1, 2, and 2. I can write a polynomial in intercept form or factor form. If my 0 was x is equal to negative 1, then my factor, I have to add 1 to both sides. My factor would have been x plus 1. If my 0 was x is equal to 2, my factor would have been x minus 2. And again, if my 0 was x is equal to 2, my factor would have been x minus 2. So I can write a polynomial with those zeros, negative 1, 2, and 2, in intercept form or factored form. Well, that would just be y is equal to x plus 1 times x minus 2 squared. I have 2, x minus 2. So that's x minus 2 squared. So the polynomial that would give me zeros of negative 1, 2, and 2 in factored form or intercept form is y is equal to x plus 1 times x minus 2 squared. And if you graphed it, you would see that. So x minus 2 squared. Notice here my 0 would be 2. I see that there. And my 0 or x-intercept there would be negative 1. And I see that there. Also want you to notice, so in what degree polynomial would this be? Well, this would be a degree 3 polynomial. Because the degree of that factor, x plus 1, is just 1. And the degree of this factor, x minus 2, is 2. So this would be a third degree polynomial. Third degree polynomial. I have a linear term here, x plus 1. And then I have a quadratic term, x minus 2 squared. So 1 plus 2 gives me 3. It's a third degree polynomial. Notice it has at most 2 bends. 1 bend, 2 bends. Third degree. And given x-intercepts of 3, -4, -4, -4, this now will have a leading coefficient, a negative leading coefficient. Factors or the intercept form, again, so if my 0 was x is equal to 3, my factor would be x minus 3 equals 0. That would be my factor. If my 0 was x is equal to -4, my factor, if I add 4 to both sides, would be x plus 4. So I have 3 x plus 4s, so that's going to be x plus 4 cubed. And then I have an x minus 3. And so the factored form, I can write a polynomial in factored form. It's going to be y. But notice here I have a negative leading coefficient, so I need to make that negative. Oops. That has to be negative. So the polynomial then, with zeros of 3, -4, -4, -4, would be y equals, the leading coefficient is negative, and then x minus 3 times x plus 4 cubed. What will be the degree of that polynomial? Well, let's see here. X minus 3 is a linear term and has degree 1. In x plus 4, it has degree 3. Okay, so the degree of that polynomial would be 1 plus 3. It would be a 4th degree polynomial. 4th degree polynomial. And if I graphed it, you would be able to see the zeros. Okay, if my factor is x minus 3, my 0 would be 3, x-intercept. And if I have x plus 4, my 0 will be x is equal to -4. And that will happen 3 times. So, all right. Now the last thing we have to do is something we've done before, add and subtract polynomials. And we'll write our answer in standard form. So to add and subtract polynomials, you combine the terms that have the same degree. So here, as I look at, so we're adding, so I have a 2x cubed and an x cubed. If I combine 2x cubed and x cubed, I should get 3x cubed. And then I have an x squared and nothing else, so I have my 5x squared. And then I have, let's see here, a -x and a 7x. And we're adding vertically. This is called the vertical method. And so that gives me 6x. And then finally, I have a 9 and 4. And that gives me 13. So to add and subtract, you combine like terms. And you write in standard form. Add vertically. Notice here, okay, they wrote the answer in standard form. To subtract, you have to remember to distribute the negative. Add the opposite horizontally. Oh, here they're using the horizontal method. Okay, so here, if I distribute the negative, that will give me, so I'll change this negative to, so this will be plus, but then negative times a positive, that will give me -x squared. A negative times a positive, that will give me, okay, well they're writing this in standard form, so that would be -6. And a negative times a negative, that will give me a positive x. Okay, so distribute that negative and then add the opposite. And here they're writing this in standard form, so 3 minus 2x squared will be -2x squared plus 3. And then they're just combining the like terms horizontally. So nothing you haven't done before. Oops. So we have -2x squared minus x squared. That gives me -3x squared. And then I have just x by itself. And then 3 plus a -6, or 3 minus 6. That will give me -3. So -3x squared plus x minus 3. So adding and subtract. we've done that before. Okay, so that's an introduction into polynomials, being able to graph polynomials using the zeros or the x-intercepts, and then adding and subtracting. Okay, so we should be able to, given the x-intercepts, write a polynomial in factored form. For example, my x-intercepts 0 was 3, -4, -4, -4. My factors would be x minus 3 times x plus 4 cubed. It has a negative leading coefficient, so the leading term would be negative out in front, and so the polynomial in factored form would be negative times x minus 3 plus x plus 4 cubed.